Hello everyone. In previous video we have covered 1 degree alcohol dehydration at 413 Kelvin temperature and we found ether is a major product there. Now in this video we will check how 2 degree 3 degree alcohol dehydrates at 413 Kelvin temperature. As I already told to you, 2 degree 3 degree alcohols will get dehydration at 413 Kelvin temperature. Major product will be alkene there. And few particles can undergo for the generation of ether. Let's check the mechanism part. First, I am going to write 2 degree alcohol mechanism. Same mechanism will be for 3 degree. 2 degree alcohol dehydration mechanism. At 413 Kelvin temperature. As we know, dehydration we are performing in the presence of catalyst, sulfuric acid, H2SO4. So let's start step 1. 2 degree alcohol I am using this one. You can check 2 degree alcohol it is. Propane 2-ol, OH connected to this carbon which is further directly connected with 2 carbons. So this is 2 degree alcohol. In alcohol, OH particle is there with oxygen carrying a lone pair. Now, in step 1, as you know, sulfuric acid will give us H positive ions which have a vacant orbital. So they are working as an electrophile. That electrophile wants electron. Who can provide electrons? Oxygen. Because oxygen is carrying lone pairs there. The lone pair, vacant orbital. They can be fit into each other well. So between oxygen and hydrogen, a dative bond will generate. This one. Out of 2 electrons, 1 electron it will shift toward hydrogen, so that positive charge of hydrogen will finish. But on oxygen, positive charge will generate. 1 electron it will keep with itself. We call it protonated ethanol. No, protonated propane 2-ol. Because this is propane 2-ol. Now proton is added on it because H positive is also known as proton. In previous videos also we have discussed it. Or oxonium salt. Highly unstable it is because oxygen is carrying +1 charge, 3 bond it is making. It is a step 1. Now step 2. This protonated alcohol which is generated over here is highly unstable. Now please check what is the difference between step 2 of 2 degree alcohol and step 2 of 1 degree alcohol. In 1 degree alcohol, there was another molecule, like suppose, let me recall it. In previous video when you will check, this is 1 degree alcohol. In step 2, this 1 degree protonated alcohol was attacked by this carbon is carrying positive charge because O is highly unstable, trying to break bond from it. So carbon is highly positive. The second molecule of ethanol has attacked on this carbon. The mechanism was SN2 mechanism. This one. But here with 2 degree and 3 degree alcohols, such mechanism will not be involved here. Only this is a difference. 1 degree alcohols are able to show SN2 mechanism, but 2 degree and 3 degree alcohols will not show SN2 mechanism, means backside attack from the another molecule. Let's check reason. The reasons are 2 there. SN2 mechanism already we have discussed. SN2 mechanism involves backside attack. And for backside attack, less crowding should be there. For more detail, please check haloalkane chapter. There we have discussed SN2 mechanism. In 1 degree alcohol, like suppose I am writing this 1 degree alcohol, protonated. Here, this is the carbon which will be attacked by another molecule. You can check here, crowding is less. Crowding is less. That's why another molecule of ethanol can easily attack from backside. That's why SN2 mechanism was happening. But whereas if we are talking about 2 degree, so this carbon is surrounded by two alkyl groups. Means crowding is there. Second molecule cannot easily attack from backside on this carbon like it was happening in 1 degree alcohol. And if we are going for 3 degree alcohol, crowding will be further increased. So no chance for the backside attack. That's why SN2 mechanism will happen only in the case of 1 degree alcohol. That's why ether was generated there. But in 2 degree and 3 degree alcohol, SN2 mechanism will not happen there. What will happen? Check. This oxygen will break bond directly from carbon and there will be the generation of carbocation. This is the second reason. Because 2 degree carbocation will generate and we know 2 degree carbocations are very stable as compared to 1 degree carbocations. So that's why 2 degree alcohol is preferring this way to complete the reaction. What will release out? H2O. Obviously, electrons will completely shift toward oxygen because oxygen is more electronegative than carbon. And this electron of carbon will also go with oxygen. So with the release of H2O, carbocation will be generated, which will be 2 degree carbocation. And if we talk about 3 degree, in that case, 3 degree carbocation will generate, which is most stable carbocation among all. So this is a step 2, which is happening over here in 2 degree alcohol case. 2 degree carbocation will generate. And then finally we will have step 3. It is highly unstable. As you know, these are intermediates. Intermediates are unstable. But if we compare their stabilities, the 2 degree carbocation is better than 1 degree and 3 degree carbocation is better than all. Now, who will stabilize it? These neighboring carbons, which we call alpha carbons. This is alpha carbon, this is alpha carbon. How they will stabilize them? I am using suppose this alpha carbon. This is a vacant orbital. This alpha carbon will completely break bond from hydrogen and will shift its bond electron here. 2 electrons are coming here, vacant orbital will come here. So these 2 electrons will be filled in vacant orbital and bond will generate. Double bond will be there now. CH3 as it is. The hydrogen is losing its electron completely, so it will release out as H positive. It will start from first step and whole step will be repeated again. It will repeat the whole cycle again. So you can check what is the product here? Alkene. The major product will be alkene because the reaction is happening with generation of carbocation, which is getting stability through alpha hydrogens, alpha carbons like this. So the major product will be alkene there. In 3 degree alcohol, same process is happening there. Now, with this reaction, some minor reactions are also happening there. Minor means this is the major product. In step 2, it was generated. Few particles, very less particles are performing this action also, SN2 mechanism. Again, please check my words, very less particles. Majorly particles are doing breakage of carbon-oxygen bond and carbocation generation and generation of alkene. But very few particles are also showing this SN2 attack, due to which you know what will happen. A transition state will generate. This is SN2 mechanism. So if I will draw transition state, bond breakage and new bond formation with oxygen, like which we have done for 1 degree alcohol in previous video, like this. This is a transition state, and finally after transition state, complete bond breakage and complete bond formation will be there. So a very less amount of ether will also generate there. Very less amount of ether, so it will be a minor product there. Because we know this attack is very difficult due to crowding, but few particles are able to perform it, due to which few ether particles can also be generated as a side product. That's why we are calling it minor product. But most of the particles are creating carbocations and creating alkene. Same problem is there with 1 degree alcohol. Most of the particles are creating ether by SN2 attack, but few particles are also creating alkene. Let me show it here. In 1 degree alcohol, in second step, this was generated. Most of the particles are showing SN2, but few particles, let me recall, few particles, what they are doing? They are doing this. Carbocation is generated, and this carbocation will be stabilized by this alpha carbon by the breakage of bond from hydrogen and shifting toward this carbon. So we will get few particles of alkene plus H positive, which will repeat whole cycle again. That's it. These are the main points. So finally, if we conclude, so conclusion is 1 degree alcohol on dehydration, and note down this is happening at what temperature? 413 Kelvin temperature. 1 degree alcohol on dehydration, major product will be ether and minor will be alkene. And 2 degree and 3 degree alcohols on dehydration at 413 Kelvin, major will be alkene and minor will be ether. Here the reaction is happening with SN2 mechanism, and here we are following generation of carbocation. Generation of carbocation. That mechanism is also known as E1 mechanism. Unimolecular as elimination mechanism. That's it. This is the end of the video. Thank you very much.